This is one of two videos that's all about how to make salts. This one focuses on how to make insoluble salts, so please enjoy. The first thing that you need to work out is whether the salt you're making is actually soluble or insoluble. So how are you supposed to know? What we use something called solubility rules. So if it's soluble, that means it dissolves in water, and if it doesn't fit these rules, then that must mean that it is insoluble. So let's have a look. All sodium, potassium and ammonium ions are soluble. All nitrates are also soluble. Halide ions are normally soluble unless you have a silver or a lead one, and sulfate ions normally soluble unless you've got a barium or a lead one. These are the main examples you'll have to deal with in GCSE. There are other examples of exceptions to these rules, but we can't put everything in here. A simple way to remembering the ones that are definitely 100% soluble is the acronym SNAP. So sodium, nitrate, ammonium, potassium represents the 4 ions that if you've got them in your salt is definitely a soluble one. Let's check out an exam style question for making an insoluble salt. So what is the method for making a pure and dry sample of silver chloride from silver nitrate and sodium chloride? So the first thing I'm going to do is to do the equation for this reaction, which is here. It's a double displacement reaction. I hope that this part is already okay. What we're going to do differently today is we're going to find out the state symbols. So if we use our solubility rules, it tells us that anything with a sodium in it is soluble. Okay, sodium salts are always soluble. So both of these sodium salts are soluble in this case. Also, any nitrates are soluble. So that means that my silver nitrate must also be soluble. Now, if we look at AgCl, that's a chloride, which is a halide salt. So halide salts are soluble unless it is a silver one. So if I've got silver chloride, that is insoluble. That means that it must be a solid. And we call any solid product a precipitate. That's the scientific word for it. So although we've done a lot of science so far, we haven't really answered the question about what is the method for making that pure and dry sample of silver chloride. The first step is to mix together your silver nitrate and your sodium chloride and stir them together. What you'll end up with is that solid AgCl being formed, and then any of the excess soluble reagents will be left in that solution. So you'll see it as a nice precipitate, a solid product being formed in that flask. Because it's the solid that you want, the solid is the product that I need, what I'm going to do is I'm going to filter it next. And what you can hopefully see is that the solid AgCl will get stuck at the top of the filter paper. We call that the residue, the solid product. All of the stuff I don't want is at the bottom. I don't really care about that anymore, just the solid at the top. So the next step is I need to really make this solid pure and dry. Now the third thing that we do is we rinse the solid with distilled water. And if you rinse it with distilled water, that means that if there's any of those soluble things that are still stuck in that solid, then it's forcing them to go through the filter paper into the bottom. Now that that solid is pure, the important thing is that we leave it to dry in a warm place, and then you have your pure and dry sample of silver chloride. Right, that's all there is for this video about how to make insoluble salts. The key difference between this and making a soluble salt is that there's definitely no heating involved in this method. So if you're making something insoluble, you never need to heat it.